Mr. Dipankar Bhattacharya, Country General Manager, India at DB-Aire India Pvt. Limited, is currently responsible for Dunham-Bush business in India. Coming with a mechanical engineering background, Mr. Dipankar also has LEED and IGBC accreditations with 2 decades of HVAC&R Industry experience. During his illustrious career, he has worked in organizations like Blue Star in Refrigeration, Thermax in Absorption Cooling and Carrier in Air Conditioning in multiple roles and locations. Today, Mr. Dipankar will give us a brief view of growth and energy efficiency in applied products in line with ICAP. So delegates, let's welcome Mr. Dipankar.
I think what we are talking about necessarily is India's cooling action plan and why it is important for us to understand that what's in store for us for maybe next 10, 20 years India and why it is important to have a robust plan around cooling. So first understand what is the cooling action plan. The cooling action plan is nothing else but creating a kind of a roadmap for sustainable cooling. We all know that space cooling or space heating, how important it is for for us because of the factors that the climate is constantly changing and there are constant requirements that are evolving in terms of either a space cooling or a space heating. Now, when we look at space cooling in India, which is the predominant factor when it comes to HVAC space, it's no secret that it's hugely underpenetrated. What I mean to say is that there are very less people that are privileged to have a space cooling facility in India. It is estimated around 4 to 5% penetration, wherein in developed country it could be as high as 60-70%. In China also it is close to about 40 to 50%. In terms of the perspective that is being presented in the India Cooling Action Plan, India's space cooling per capita consumption in kilowatt hour is only 69 watts. When you look at some of the other either developing countries or developed countries, it's far higher. I mean, US being the highest, close to about 1.9 kilowatt is what they're consuming for space cooling per capita. Even countries like China is also having close to about 6 folds. Important for us to know is that the scenario is changing. Next 10, 15 years, the scenario could be huge urbanization happening for last decade or so. There are instead of getting their new. So of course, with that, the cooling requirement is also increasing. So the cooling action plan was introduced in 2017, and if you look at a 20-year horizon, what we're looking at is close to about 4.5x growth in the energy consumption as far as India cooling is concerned. So from close to about 135 terawatt hour, it is going to become something like 600 terawatt hour in next 20 years. That's the projection has been, and that's like almost 4.5x jump in terms of power consumption. Now, of course, India also has a very stiff target to meet in terms of being net zero. I think our honorable Prime Minister Mr. Modi has in recently concluded week, he has promised that India will be a net zero country by 2070. So one side you have the challenge of meeting the cooling demand and the increased power consumption towards cooling towards space cooling, and also on the other hand you have the challenge of becoming a net zero country by 2070. So how this is possible? How we can possibly make this happen without the comfort in the conditions, space being suffered. So one option, there are 3 things that come to my mind, and necessarily in this forum I'm talking about commercial applied cooling, so which is about close to about 20% of the consumption, energy consumption that we have for typical space cooling requirements. So commercial applied, for everyone's benefit, is the large requirement that you have on space cooling. So when you look at a commercial building, or you look at a hospital, look at a large hotel, look at a large institution, the cooling that is deployed there is commercial cooling. Typically what we have in our home is called domestic cooling, or we call it residential cooling. So there is a difference, but I'm not talking about domestic cooling now, which is also a significant chunk of the industry in terms of business number, in terms of power consumption, and government is doing exceedingly well in ensuring that the energy levels are being taken to the next level in domestic cooling as well. I will not discuss about that. I'll focus on commercial cooling. When you talk about commercial cooling, there are components like electrical chiller, the component like VRF systems. There are components like ductable, of course, that come into light commercial category, ductable and package. They would form the entire commercial and and light commercial business. So in terms of that business, we are also looking at multifold growth. So when you talk about, let's say, the chiller systems, which generates chilled water, and that is in turn circulated in the conditioned space, we are looking at close to about 5x growth in that in next 20 years time. And we are looking at close to about 13x growth for the VRF system as well. So both are quite significant. And we'll have to be mindful about the fact that if the space cooling requirement in commercial business is growing, the energy consumption is also going to grow. So how to ensure that the energy consumption is kept in check? There are actually three ways to do that. One, of course, my fellow speaker, Shruti, has already spoken about that. There is no two ways about or there's no alternate to the sustainable development. So how can you make it more sustainable? How can you make it more friendly? How you can make the overall building envelope and the systems more energy efficient or more sustainable is one of the most important factors. So this will, of course, reduce the cooling load, which is what is need of the hour, because if you do not build sustainably, if you do not bring in the element of passive design, I think she spoke about that to a great length, you will not be able to create a sustainable built environment, which is one of the key necessities that we have today. With the rapid urbanization that is happening, with the rapid growth in building infrastructure that is happening, it is important that we bring in the element of passive design, we bring in the element of sustainable building materials to be able to create an environment where the cooling requirement itself is less. The second important factor is the equipment that gets into a building. So when you talk about the applied industry, the products that are being offered, we have seen a rapid change in those product lines also. So if I'm not wrong, ECBC was introduced sometime in the year 2007, and since then it has grown by leaps and bounds. And I think Shruti also spoke about that, how some of the states have made the ECBC norm integral to their bylaws, and kind of made it mandatory for the building industry to adopt that, which is a great initiative and a great push by the Bureau of Energy Efficiency. And we'll have to ensure that it's more and more adapted, because when I look at the ECBC of 2007 versus today, I think there's an increase in energy efficiency requirement that has happened, and that is to the tune of 10 to 12%, which may not sound very significant, but if you look at, you talk about the industry, the applied products, 10% increase is quite significant. What has also happened is, the consideration of the load that at which the building operates versus the load at which the chiller operates, and to ensure that the equipment that gets into a building responds to the varying load of the building, because the building load will vary depending on the internal load, depending on the external load, depending on the season. If your equipment is not geared enough to respond to this varying load and adjust its operations suitably to be able to deliver the best efficiency and operate at the best efficiency zone, then obviously your building will not be efficient. It will not be able to run efficient. So that has happened over the last 15 years. We have seen rapid adoption of variable frequency drive based chillers, which delivers very good efficiency on part load conditions. And because of that, the overall building efficiency has also gone up by significantly by leaps and bounds. So this is one thing that is happening. We have seen constant evolvement of technology. There are products that are coming that are even better than ECBC, Super ECBC. So Super ECBC asks for 6.7. We have products which even delivers above 7 COP. And that has only happened because the constant evolvement that happened in terms of the compression technology or the heat exchanger technology or the control technology. And I think this will continue in coming years as well. The third most important factor is the transition in refrigerant. So when you talk about the refrigerant, if you see the transition of refrigerant happened last in 20 years time, we have seen the refrigerant coming from HFC to first it was HCFC, and then it became HFC, and then now it has become HFO, which is having very less global warming potential, almost negligible global warming potential, and zero ozone depleting potential. Of course, HFCs were also zero ODP refrigerants, but then for some of them, the global warming potential was really high. That has been eliminated by the introduction of HFO refrigerant, and more of the applied products are being designed for HFO refrigerants. Of course, we have certain challenges in some of the HFO products, but still we have seen rapid adoption of even HFO refrigerants as well with certain product lines. Today, if you ask me, are they commercial success? Probably they are not. Sparingly, people are taking HFO-based products. But of course, in next 10 years, 15 years, 20 years time, the scenario is going to change. I think the decision will be more on HFO refrigerant rather than HFC-based refrigerant, because we also have signed the Kigali agreement, by which we are talking about rapid reduction of HFC-based refrigerant, which could be detrimental to the ozone layer. So the whole point is that industry is moving in the right direction. The adaptation is happening. Of course, it's gradual, because for any trend to change, it will take a few years, and we'll have to be patient. I think government is also doing a great job by introducing energy conservation codes, by introducing mandates, by introducing standards, and that will continue in coming times also. So overall, I think the whole point here is that I am extremely hopeful that with the rapid industrial growth that is happening, with the rapid increase in the cooling requirement that is increasing, this is a gradual adaptation that is happening, which will also bring down the energy consumption of the equipment, just to kind of create a balance between the growth in consumption that is happening versus the energy consumption of the equipment. The last but somewhat important topic that I want to touch upon here is it's very important that we have an integrated design approach, because it's clearly established that some of the energy efficient equipment, when installed in a building, it's not exactly operating with the building envelope, the building load. It's the delivery is not in sync with the building load. Okay, the equipment that go into a building could be efficient individually, independently, but when they operate in a system, probably not they're delivering that great efficiency as a system. So that is why it is important that we take an integrated approach, in ensuring that the equipment talk to each other, they deliver the right efficiency as a system, and not only individually or not only on paper. And for that, the control mechanism is also going to play a major role. So the integration of the components, let's say in a typical building for the applied products, there are components like you have a pump, you have a cooling tower, you have a HU, you have a chiller. How those things can be integrated through a control mechanism, through a chiller plant manager or chiller plant optimizer to deliver the best efficiency at any load condition of the building is most important, and there should be a mandate on that as well. I think we already have seen that kind of initiative in Singapore, wherein people do not talk about independent efficiencies. People no longer talk about independent equipment efficiency. They talk about efficiency at the system level. So that is an important aspect. But overall, I am bullish and I am very optimistic that things are moving in the right direction. And this India Cooling Action Plan, actually, it augurs well for India, for a developing country like India, and the way the landscape is changing, the infrastructure development is happening. I am really hopeful that we'll have a very exciting time. Thank you so much.